Okay, in our last topic in Chapter 7, we're looking at Topic 7.5, Modeling Data Using Logarithmic Functions. This is about problem solving. This is on page 460. In Example 1, and we're only going to do one today, how to use logarithmic regression to solve a problem graphically. Well, in our first problem, and our only problem, caffeine is found in coffee, tea, and soft drinks. Many people find that caffeine makes it difficult for them to sleep. The following data was collected in a study to determine how quickly the human body metabolizes caffeine. Every person starts with 200 milligrams of caffeine in his or her bloodstream, and the caffeine level was measured at various times. Here's the chart of the caffeine levels in our bloodstream and the time in minutes, or time in hours, after we've ingested it. So there's going to be different. We're going to make a scatter plot with this information, and what we're going to do is ask you to enter this data into your calculators, into L1 and L2, and then we're going to use logarithmic regression, which is stat, calc, which is the right arrow, and 9, to determine the regression equation that's going to best match our data. And if you do this, you're going to use 9, which is y equals a plus b times the natural log of x. Okay, so now we're going to ask you to determine the equation of the log regression function for the data that represents the time as a function of the caffeine level. And if you plug your information in and you press that regression, it comes up with this equation. Y is equal to 44.392 minus 8.357 times the ln of x. Now, if you look at the bottom, what you're going to do is you're going to draw a scatter plot of that information by turning your stat plot on, and then plugging this equation in, you're going to hopefully get this picture. And it's going to have a scatter plot with a bunch of boxes, and you're going to have a line of best fit, a curve of best fit, that's going to go through it. Part B, determine the time it takes for the average person to metabolize 50% of the caffeine in his or her bloodstream, and round your answer to the nearest tenth of an hour. Well, if everybody started with 200 milligrams, 50% is going to be 100 milligrams. So what you're going to do you're going to put this in your calculator and trace, and you're going to see, let's stop this. You're going to see, if you traced it along your curve, that it's going to be, the numbers I get are going to be anywhere between 5.6 and 5.9 hours. And then last, Paula drank a cup of coffee that contained 200 milligrams of caffeine at 10 a.m. How much caffeine will be in her bloodstream at 9 p.m.? Well, that's 11 hours after taking it. So when you look at your graph and you see time and go to 11 hours and draw a line across, you're going to see it's going to intersect the graph at about 54. So that tells us that after 11 hours, Paula would expect to have about 54 milligrams of caffeine left in her system. So that's how we're going to be doing regression equations with log functions. We're going to plug the information in our calculators. We're going to generate an equation, and we're going to, from there, be able to answer the questions from our graph, just like we've done in past chapters. So your assignment then is to do the problems on page 466. I want you to do questions 1, 2, 3, 5, and 7. That ends Chapter 7.